Hello and welcome to our Logical Functions in Excel course. My name is Deborah Ashby and I am excited to be your guide as we dive into the world of logical formulas. This comprehensive course will cover everything you need to know about the backbone of decision making in Excel. Now let's take a quick look at what we'll cover in this course. We'll start out by exploring the fundamental and, or, and if functions. Let's discover how the if function can help us make decisions based on true or false conditions. We'll then delve into nested ifs, a technique that allows us to create complex decision trees within our formula. If you thought that was impressive, then get ready as we talk about the if-s function, which will allow us to create multiple conditions within a single formula. Moving on to everyone's favorite conditional ifs. We'll explore SUMIF, COUNTIF, AVERAGEIF functions for single criteria and the powerhouse combination of SUMIFs, COUNTIFs, and AVERAGEIFs functions for multiple criteria. But we don't stop there. Because we all encounter errors from time to time, we'll wrap up by mastering error handling. We'll talk about using if-error and if-NA to handle and troubleshoot errors within our logical functions. By the end of this course, you should have a solid understanding of logical functions in Excel and the skills to apply them effectively in your real-world projects. Now, we believe in a hands-on practical approach, so you better get ready to roll up your sleeves and work on the course exercise. Let's embark on this learning journey together, and I'll see you over in the course.
Welcome to the course. Please watch this video as we have some important information that you'll need to get the most out of this class. This course is video-based, but does include downloadable exercise and instructor files. The exercise files relate to specific exercise videos. Don't worry though, your instructor will tell you which files to open for each exercise. The instructor files are the files we used when creating the video sessions. You can follow along if you wish, but that's entirely optional. You can download the files from the next module, and here's how. Once you've downloaded the files, you'll need to unzip them. If you've not unzipped files before, here's how. All of our videos are high definition. Depending on your internet speed, Udemy may default to a lower playback level. We recommend viewing in high definition. Here's how you can change that. If you want to speed up or slow down your video playback, you can do that too. And here's how. Udemy may ask you to review this course after you've only completed a few modules. We know that can be annoying, as it's like being asked to review a 2-hour movie after 5 minutes. It's up to you when you want to leave a review. We hope you enjoy the course.
In this section of the course, we're going to dive into the magical world of using logical functions in Excel. Because logical functions are some of the most important functions that you can know or have in your toolkit when you're working in Excel, particularly if you're an intermediate user. And what logical functions help us do is basically make decisions. Now, there are quite a few different logical functions. You'll find them on the Formulas tab in the Logical group of the function library. And you can see all of them sitting in there. And we're going to use quite a few of these throughout the balance of this section. But what I wanted to make sure that we do in this first lesson is just do a quick recap on some of those basics, just to make sure that we're all on the same page and we're starting from the same baseline. Because it's really important to understand the concept behind how logical functions work before we can move on to doing more complex calculations using things like ifs, SUMIFs, COUNTIFs, and nested if statements. So let's talk about logical statements in their most basic form first of all. And we're going to do this using an example because it's always the best way to visualize this. So on this first worksheet, I have a very small table, and this lists out some expenses. So we have the person's name in here, we have the total of their expenses, and what I want to do is work out if an approval is required. Now we have some additional information next to this that says expenses over the following amount must be approved. So if the expense is over $1,000, then it needs to be approved by a manager. So I can work this out by using a very simple logical statement. Now, what exactly are logical statements? Well, it's basically like performing a test. So in this particular example, if we take the first expense just here, I would want to construct a logical statement that says if this value in cell B5 is greater than or equal to this value in cell G5, then it needs to be approved. And I want to perform that same test on all of these expense invoices. Now, when we're doing things like this, we use what we call operators. And you can see I've just pasted in a little picture of a table that shows different operators that you might be using in your logical statements. So things like equal to, greater than, less than, greater than or equal to, so on and so forth. So let's do this first one just here. We're going to type in equals to let Excel know we're about to do a formula, and this is very straightforward. We perform our test. So is the value in cell B5 greater than or equal to, we're going to say that because if it's 1,000 dead on, it needs to be approved. Is it greater than or equal to the value in cell G5? Now remember, if you want to copy this formula down, we don't want that figure in cell G5 moving, so we need to lock it by pressing the F4 key and making it absolute. Now if I hit enter just here, it's given me a result of false. And what I can do is I can now copy that formula down, and I can see here that all of the results showing as true are the invoices that are greater than or equal to 1,000 and need to be approved. Now notice here that all of my answers are either true or false. And if you perform a logical calculation in this particular way using these operators, the output is always going to be true or false. Now that might be absolutely fine for whatever it is that you're doing, but sometimes it might be that you want to make this more meaningful. So instead of it saying false just here, I might want it to say okay. Instead of saying true just here, I might want it to say approval. So effectively what I might want to do is attribute meaning to the true and false values. And I'm going to show you how you can kind of move on from this and do that in the next lesson. But for now, let's just get this concept of logical formulas straight in our head. We perform a test. Now, because of the way that I've set this up, if this threshold in cell G5 was now to change, so maybe this now changes to 1200, notice that all of my results update. If I was to change this to 500 and hit enter, everything is now true. Okay, so a really nice effective way of putting this formula in and making it dynamic and easy to update. Now, just to go back to changing these values and adding meaning to them. In order to do that, instead of just having our basic logical function, we would need to turn this into an if statement. And that's basically what an if statement allows us to do. It's basically this same logical formula, but it allows us to attribute more meaning to the results. And we're going to cover if in a lot more detail in the next lesson, but let me just show you how we would change these values. Now I'm just going to delete these out. Now what we're going to do is we're going to wrap basically our logical statement inside an if statement. Now notice here it says check whether a condition is met and returns one value if true and another value if false. So the first argument here is our logical test. So our logical test is pretty much what we just did. Is this value greater than or equal to this value? F4 to lock. Press comma to move on to the next argument. This is where we can attribute meaning to the true or false result. So it says value if true. I can now define what I want it to say if the result is true. So if the result is true, effectively the number is greater than 1,000 and it has to be approved. So in quote marks, because text in formulas must always be in quote marks, I want it to say approval, comma. If the value in the cell is false, I don't want it to do anything. I just want it to say okay. Let's close the bracket. So I've attributed meaning to the true and false results. Let's hit enter. And I can now double click to copy that down, and it's a lot clearer for me to see which invoices need to be approved. So simply by adding in that if statement, we've changed the rather generic true or false output to something that's more meaningful and easier to understand. And that's basically what an if does for us. Let's look at a few more examples of if in action. Now in this first table, again, a very small table, we have some test scores. So we've got some student names and we've got the score they achieved in a test. And the pass mark is 85. So I want to create an if statement that says if the value in this cell is greater than or equal to the value in this cell, 85, I want a result of pass. If it's not, I want a result of fail. So again, we're going to use if. Our logical test is if the value in B4 is greater than or equal to the value in H3. We're going to copy this down, so F4 to lock. If that is true, then they have passed. Hooray! If it's false, then unfortunately they have failed. Close the bracket. I'm going to do a Control Enter to stay in the same cell. Copy that down and I get my results. So much more meaningful than simply true or false. Let's take a look at another example of if. And we're going to add in a little bit more complexity just here. So in this second table, we have some products, we have the weight in kilos, and then we have the price for those products. And I'm actually just going to change these to dollars just to keep everything in this spreadsheet consistent. Now what we're going to say here is that if the weight of the product is greater than or equal to 30 kilos, then there's going to be a 20% shipping fee. And that shipping fee is going to be 20% of the price. So let's construct our if. What is our logical test? Well, if the weight is greater than or equal to 30 kilos, again, F4 to lock. Now, what do we want it to do if that is true? So if the product is greater than or equal to 30 kilos, well, there's going to be a 20% shipping fee. So our true result is going to be a calculation because we want it to work out that shipping fee. So if it's true, we want to do the price multiplied by 20%. F4 to lock, comma. If it's false, there's going to be no shipping fee. So we're going to put a 0 on the end there. Close our bracket, Control Enter to stay in the same cell. And if I copy this down, I should find that the only two products that have a shipping fee are the ones that are greater than or equal to 30 kilos. And this amount should be 20% of the actual price. So we can incorporate formulas into our logical if statements as well. Now I just want to finish off this lesson by running through a couple of other basic logical statements, and that is and or. Now what and allows you to do is basically perform two logical tests. So we're taking this example of test results again. So we have our students and we have the score they achieved in test 1 and the score they achieved in test 2. And what we're going to say is that they need to have achieved above 75 in test 1 and above 65 in test 2 in order to get a result of pass. So we're effectively performing two logical tests here. So if we want to do more than one, and we need both of these to be true to get a positive result, we use the AND formula. Notice the arguments logical 1, logical 2. So our first logical test is if this score is greater than or equal to the pass mark for test 1, F4 to lock, and the second test score is also greater than or equal to the pass mark for test 2, F4 to lock. Both of those have to be true in order to pass. Now I'm going to hit enter. It's going to give me a result of true or false. If I want to add meaning to this and have pass or fail, I would need to edit this formula and wrap it in an if statement. Remember, that is how we add meaning. The first argument for our if statement is the logical test. Well, those are being generated by our AND formula. So I can go straight to the end and just define what I want it to say. So if both of those are true, it's going to be a pass. If both or one of those are false, it's going to be a fail. Close the bracket, hit enter, and now I've combined two functions together to perform two logical tests, and I've given them meaning using if. OR works in a very similar way, except what we're saying here is that they need to have achieved the pass mark in test 1 or in test 2 in order to achieve a result of pass. So we're going to go straight in and type in our if formula. Our logical test, well, we want to generate this using our OR calculation. Logical 1, logical 2. So if score 1 is greater than or equal to the pass mark, F4 to lock, or score 2 is greater than or equal to the pass mark for test 2, F4 to lock. Close off our OR. We're now back into our if statement. We can now set up the value if those are true. So if that's true, we have a pass. If it's false, we have a fail. Control, enter, and then I can copy that down. So notice here that the only one that comes up as fail is where both of these scores are less than the pass marks. So we've looked at basic logical functions there. We've seen AND, we've seen OR, and we've seen how we can add meaning by using if. And in the next lesson, we're going to look at if statements in a lot more detail. In this lesson, we're really going to isolate that if function and take a look at it in a little bit more detail. Now, we saw in the previous lesson some basic uses of if and how we can use if to add meaning to true or false results. Now, the ifs that I've showed you so far, we've been typing them directly into the cell. Now, that might be your preferred method, but also remember that you can use the functions dialog box if you find that a little bit easier. Now, you can access your functions dialog box simply by clicking on this FX icon and then searching through your functions list for the function that you want. So in this case, if I click go, there it is at the top. Alternatively, I could jump across to the Formulas tab, and in my functions library from the logical group, I could choose if. And that's basically going to open up my arguments, but in a dialog box as opposed to just having them appear underneath the formula in the cell. Now, some people find this method a lot easier, particularly when they're learning more complex formulas. I'm somebody who prefers to just type it into the cell, but I'm going to show you this example using the functions dialog box so you can see the other option that you have. Now, before we get on to doing this, let's just take a look at our data. So here I have a list of furniture sales for 2018 and 2019. We have the products listed in column A, the customer, the date, the item cost, the number of items they purchased, and the total cost. And the total cost is a calculation. It's basically the item cost multiplied by the number of items. And what we need to do here is complete the shipping column and the total column. And I can see over here for orders over $1,500, there's going to be a shipping charge of 2% of the cost. So we need to make sure we incorporate this calculation into our if formula. So let's widen out this column just a little bit so we have more room. And I'm going to click in cell G4. Let's jump up to Formulas, into logical and select if. Now notice as soon as I've done that, it's put the word if into the cell, and now I can perform my logical test. So my logical test in this scenario is if the total cost in cell F4 is greater than 1500. Now, if I'd hard-coded 1500 into here, the formula is still going to work. But this goes back to one of those golden rules I was speaking about earlier. If you do hard code your numbers into your formulas and then those numbers change, it means you're going to have to go back in, find the formula and edit it, and then copy that formula down for however many rows that you've got. It's much more beneficial, efficient and safer to use a cell reference instead. So that is why instead of typing in 1500, I would in general have the amount listed in a cell so I can simply select the cell. So if this value changes, I only need to update it in one place and all of my formulas will update automatically. Now I am going to copy this formula down, so we need to make sure we lock cell K3 so that it doesn't move, F4. And notice here in this functions dialog box, it's telling me what the result of this logical test is for this first row, which is false. So here the total cost is not over 1500. Now I can specify what I want it to say if this is true. Well, if the total cost is greater than 1500, we need to apply a 2% shipping charge. And that is 2% of the total cost. So we need to perform a calculation here. So if it's true, we want to do the total cost multiplied by 2%, the result that we have in K4. F4 to lock that cell because we're going to copy it down. If it's false, so if it's under 1500, well, there's going to be no shipping charge, so I can simply put a 0 in there. Let's click on OK and double click to copy that formula down. Notice for all of the values which are under 1500, we have no shipping charge, but as soon as we get to one that is over 1500, the shipping charge is 2% of that total cost figure. So now, just to complete this table, we can perform a very simple sum calculation. We just need to add together the total cost and the shipping cost. Control Enter and double click to copy that down. So now if any of this information changes over here, so maybe for orders over 1,000, when I hit Enter, my table's going to update and I've only had to change it in one place. If the percentage changes, so maybe it changes to 5%, I can simply change it here and all of my numbers are going to update. So everything is very efficient. In the previous couple of lessons, we started to explore the usage of if to make logical decisions. And in this lesson, I want to move your knowledge on a little bit and start talking about nested if statements. Now you might be thinking to yourself, what on earth are nested if statements? Well, basically what they are if statements inside other if statements. So let's take a look at an example of what I mean. Now in this table of data, again, we just have some employee data. So we have employee names, location information, department, the date they were hired, the number of years they've been at the company, their salary, and then the job rating. And it's this column here that is going to be important in this particular lesson. Because what we're trying to do here is we're trying to dish out end-of-year bonuses based on that employee's job rating. And notice I have another little table on the right-hand side, which basically sets out the bonus amount assigned to each job rating. So if they have a job rating of 5, which is the best in this case, they're going to get a bonus of $3,000. If their job rating is 4, it's going to be $1,500, 3, 900, 2, 100, and if it's 1 or 0, they're going to get nothing. So what I'm having to do here is basically I need to perform multiple logical tests. Because I want the formula to look at this cell and say, if it's 5, the bonus is this amount. If it's 4, the bonus is this amount. If it's 3, the bonus is this amount, so on and so forth. And this is where nested if statements come in. And I will say these can get quite complicated, but when you break them down, they're actually pretty logical. So let's take a look at how we would construct this. Now, the result that I'm actually looking for in column H is I basically just want it to output the amount of the bonus. So 3,000, 1,500, 900, so on and so forth. I don't want it to say bonus or no bonus at this stage. So we're going to type in equals if and open our bracket. So we want our first logical test. So we're going to say if the job rating in cell G4 is equal to 5, which we have listed in cell J4. Remember, I could have hard-coded this in and typed 5, but we want to try and get away from hard-coding in values and use the cell reference instead. Now I'm going to lock this cell because I don't want it to move. Now, if that is true, they're going to get a bonus of 3,000. So I simply want to select the cell and again, make sure that I lock it, comma. Now, normally at this stage, I would then go and type in the value if false, but I need to add in more logical statements. So I'm going to go straight into my second if. And this is where we get the terminology nested ifs, because you have if statements inside other if statements. And I basically go through this process again. So if the job rating is equal to 4 this time, so J5, lock the cell. If that's true, they're going to get a bonus of 1,500, lock the cell, comma, next if statement. If the job rating is equal to 3, then they're going to get a bonus of 900. If the job rating is equal to 2, then they're going to get a bonus of 100, and then the final if, and then we have our final if the job rating. Now I could put here equal to 1, but if they've got a 0, I also want it to include that. So what I'm going to say is if it's less than or equal to 1, then they're going to get nothing. And then the value if false is going to be 0. Now that is a really long formula, and it's a little bit easier to see in that formula bar. Now when you're constructing formulas like this, remember you need to close off as many brackets or parentheses as you've opened. So I've got quite a few there. If I count them, I think I've got about 4 or 5. So let's just add 4 onto the end here. When I hit enter, if I haven't got enough, which I haven't in this case, Excel is going to automatically correct me. So I'm going to say yes to select the correction. Let's double click to copy this formula down, and I should find that everything in here works. So the job rating of 1 is going to give a result of nothing, which is correct. A job rating of 4, they're going to get 1,500. Job rating of 5, 3,000. Job rating of 2, 100, so on and so forth. Now notice here that I have this little green triangle in the corner. This is denoting that there is some kind of warning or maybe an error on these cells. And what this is basically telling me, if I click this little warning icon, is that I have unprotected formulas. So it's a long formula that I haven't protected. So anyone can go in here and make changes to this formula. Now I'm actually fine with that. So what I'm going to do is Control Shift down to select all of the cells. And I'm going to say ignore error just to get rid of those green triangles. Always worth checking your warnings. Sometimes they are errors that you need to fix. Sometimes they're just kind of notifications letting you know that maybe you haven't included enough data, or maybe in this case, a long formula is unprotected. So that is a nested if statement. We have if statements inside if statements. Now it might be that I want to do this in a slightly different way. So maybe instead of having the actual bonus amounts listed out just here, maybe I just want it to say if they're going to get a bonus or if they're not going to get a bonus. Because basically everybody with a job rating of 2 to 5 is going to get a bonus. It's only those with a job rating of 1 who aren't going to get a bonus. So Control Shift down, I'm going to delete this formula out and we're going to just reconstruct it in a slightly different way. So we're going to say if our logical test, if the job rating, now this time I'm going to say, is greater than or equal to 2, remember we need to lock that. If that is true, then they're going to get a bonus. If that is false, so if the job rating is less than 2, they're not going to get a bonus. So that formula is a lot shorter to construct. So it really all depends how you want to do these and set this up. Now I will say that with that nested if statement, it is a very long formula. And there is a newer formula that's been released in the later versions of Excel, so from Excel 2016 onwards, called if-s. Not to be confused with nested ifs, we have a formula called if-s. And if I type it into a cell, you can see it sitting just there. Now this is a way to make our nested if statement formulas a little bit shorter. I will say not that much shorter, but a little bit quicker to construct. And that's what we're going to take a look at in the next lesson. In the last lesson, I showed you how you can create a rather long nested if statement in order to perform multiple logical tests. And what we ended up with was a pretty long formula. Now, I did mention that in recent versions of Excel, there's been a new formula added called if-s, which makes constructing nested if statements a little bit more efficient. And I emphasize the word a little bit. It really just means you don't have to keep typing in if each time. You can go straight into the logical statement. So it is a little bit more efficient, but don't be expecting it to drastically decrease the amount of time you spend constructing this formula. So let me show you a couple of different examples. Now we're going to do the same example again, just so you can see how it compares to the nested if statement on familiar data. So if I want to do basically the same thing as what we did in the last lesson and output the bonus based on the job rating, instead of doing all of those if statements, I could use the if-s function. I'm going to press the Tab key to select it from the list. Logical test 1. So we're doing the same thing here. So if the job rating in G4 is equal to 5, F4 to lock that cell, if that is true, we want it to return a bonus of 3,000, F4 to lock the cell. Now in the old nested if way of doing this, we would then need to go in and start typing in our if statement. Now with the if-s function, we don't have to do that. We can literally go straight into logical test number 2. So we don't have to type in if, we can simply say if G4 is equal to 4, F4 to lock, then they're going to get a bonus of 1,500. We don't need the if statement again. We can say if G4 is equal to 3, then they're going to get a bonus of 900, so on and so forth. I also don't need a false argument here, so I can literally carry on going through. I'm going to stop there because I think you've got the idea. I simply need to close my bracket. If I do a Control Enter and then copy down. Notice that for the ones that I've set this for, so job rating 5, 4, and 3, I have values in there. Now this time I have NA because I haven't assigned job ratings 1 and 2 to anything. So Excel doesn't know what to do here, so that is why I have an NA error. And towards the end of this course, I'm going to show you how you can deal with things like NA errors in your worksheet and make those more meaningful as well. But hopefully you get the idea as to how if-s works. It's basically the same as doing nested if statements, except you don't need to keep typing if into the formula, and you don't need to provide a false result on the end. Let's take a look at another example of how we can use if-s. Now here we're going to construct a basic if-s formula that's going to return the day of the week when a day number is typed in. So the way that I see this is that Sunday is day number 1, Monday is day 2, Tuesday day 3, so on and so forth. And I want people to be able to come down here and enter in number 4 and have it return the day from this list above here. So we can do this using if-s. So we can say equals if-s. So if the value in this cell, which is currently empty at the moment, is equal to 1. Now I am going to hard code this in here, but as I said, you may want to list 1 to 7 out somewhere in your spreadsheet so you can use that cell reference. But for the time being, let's just leave it on 1. So if the number in A11 is equal to 1, if that's true, I want it to return the result of Sunday, comma. Straight into logical test 2. If the value in A11 is equal to 2, it's going to return a result of Monday. I'm going to carry on going. So if A11 is equal to 3, we're going to get a result of Tuesday. So let's just carry on going through all of these. If A11 is equal to 4, then we're going to get Wednesday. A11 is equal to 5, we're going to get Thursday. If A11 is equal to 6, then we're going to get Friday. And then finally, if A11 is equal to 7, we're going to get Saturday. Close off the if-s and hit enter. Now, currently we have an NA error in here because I don't have anything in cell A11. And this formula consistently refers to that cell looking for a number. But now if I add, let's say 2, it's going to give me my result. Let's add 7 and it changes. If I add something outside of the criteria that I've specified, I'm going to get an NA error. Now it might be again that you want to add in some error checking so that if somebody types in a number outside of 1 to 7, instead of just getting NA, you want it to say to them, please type a number between 1 and 7. And we're going to explore how we would do something like that towards the end of the course when we look at error checking. But those are a couple of different examples of how you can use if-s, and hopefully that illustrates quite nicely the differences between nested ifs and the if-s formula. I recently conducted a poll on LinkedIn where I asked all of my followers and connections to let me know which functions in Excel they find the most useful. And by far the clear winner was countifs and SUMIFs. And both of these functions, as well as their sister functions, average-if, min-if, and max-if, are effectively if statements which have conditions or have criteria. And there's a really important distinction to make here. In this lesson, we're going to talk about COUNTIF, SUMIF, and average-if. In the next lesson, we're going to talk about COUNTIFs, plural, SUMIFs, average-ifs. And those latter three are newer additions to Excel. The original functions that we've had for quite a while now are the singular COUNTIF, SUMIF, average-if. So let's start out in this lesson by taking a look at how those work, and then we'll add a bit of complexity to it in the next lesson. What we have here is a small table. We have some sales team members. We have the company that they work for. We've just got 2 companies in here. We have their job titles, so they're either a sales rep or a sales manager. And then we have the total amount in dollars that they've sold. Now, what I want to find out is some information, but based on criteria. So if we take a look at this first table and just concentrate on this first one, my criteria is going to be Microworld, because what I want to work out here are the total sales for Microworld. So we're adding in a condition where we have to tell the formula, perform a sum calculation of the total sales, but only when the company is equal to Microworld. So we only want to add up those total sales. So in this scenario, where we have one piece of criteria, which is Microworld, we use the singular form SUMIF. And this is a fairly straightforward calculation to do. So let's type in equals SUMIF. What arguments do we have here? Well, our first argument is range, our second argument is criteria, and then we have a third optional argument. How do I know this is an optional argument? Well, it's enclosed in square brackets. So every time you see an argument that has square brackets around the outside, it means it's not a mandatory piece of criteria. You don't have to include it in order to get this formula to work. Now we are going to include some range in this calculation, so we're going to use all of the arguments. Now our first argument here is range, and then we have criteria. Now I like to work backwards when I'm thinking about this. What is my criteria in this formula? Well, my criteria is microworld. So my range is going to be wherever I'm going to find the word microworld. So I'm going to find that in the company range. So my first argument here is the range, and then I can specify the criteria that I'm looking for. So the criteria I have listed in cell F6. Now again, I could have hard-coded in the word microworld, in quote marks of course. But as I said, wherever possible, try and use cell references. Now the final argument here is that optional argument of sum range. Now in this case, I do need this, because otherwise Excel isn't going to know what I want to add up. I haven't told it to add up the total sales yet. So my sum range is going to be total sales. Close the bracket, hit enter, and there is my result. So let's review. We're saying sum if the company range equals microworld. If it does, sum the total sales. So that is sum if, where we use a single piece of criteria, in this case microworld. Let's take a look at how this would work if we're counting as opposed to summing. So in this second example, again, we have one piece of criteria. I want to work out the total number of employees at Computech. So effectively, I want it to look through this table, and wherever it finds Computech, I want it to count the number of entries, and that's effectively going to give me the number of employees that work there. So for this, we have one piece of criteria, so we're using count if singular. This time we have two arguments, range and criteria. Again, I like to work backwards. My criteria is going to be Computech. Which range am I going to find that in? I'm going to find it in the company range. Comma, my criteria is Computech, effectively cell F14. Close the bracket, hit enter. It's telling me there are 6 employees at Computech, and because my dataset is reasonably small, I can just do a quick visual check just there, and yes, I do have 6 employees. It's also worth noting that down in the status bar, if you take a look over on the right hand side, it's telling me the count is 6. Now if you can't see that information, a little quick tip here, if you right click in the status bar, make sure you have average count, numerical count, min, max and sum turned on, so that when you start selecting things in your worksheet, you can see all of those values in the status bar at the bottom. So let's do the final calculation down here. This is just doing an average. So this time I want to find the average sales for Computech. Again, one piece of criteria. So this time we're going to use average if in its singular form. We have 3 arguments just here. My criteria is Computech, so the range is going to be company. The criteria is Computech, and the average range, well, I'm looking for the average of the sales. So I want to use the sales range. Close the bracket, hit enter, and now I get my average. So that is how we can use those 3 super useful formulas to return results based on one piece of criteria. In the next lesson, I'm going to show you how you can do the same thing, but how we can incorporate multiple pieces of criteria. In the previous lesson, I showed you how to construct 3 conditional if formulas, sum if, count if, and average if. And all 3 of those formulas use one piece of criteria. So now what we're going to do is we're going to move our knowledge on a little bit, and I'm going to show you how you can use count ifs, sum ifs, and average ifs to create formulas that use multiple pieces of criteria. And I will say that these formulas, the plural versions with the S on the end, these are newer formulas in Excel. These were introduced a few years ago, and they've quickly become the favorite formulas of a lot of people simply because they are so useful. Now let's take this first example. The only real difference between sum ifs and sum if is the number of pieces of criteria we're using in the formula. When we use a sum if, we can only specify one piece of criteria. Whereas if we use sum ifs, we can specify multiple pieces of criteria. So let's take a look at this second example. What I'm trying to do here is work out the total sales for all sales reps who work at Microworld. So I have two pieces of criteria here, Microworld and sales rep. So because I have two pieces of criteria, I need to use sum ifs as opposed to sum if. Now another difference between this formula and the sum if formula is the way that the arguments are organized. In the sum if formula, the sum range argument is at the end and you specify your criteria and range first. Whereas when you're using sum ifs, you're asked to specify the sum range first of all. And I actually find this a lot more logical to understand. So the first thing we need to do here is specify the sum range. So what are we trying to add up? Well, we're trying to add up the total sales. Criteria range 1. What is our first piece of criteria? Well, our first piece of criteria is going to be Microworld. So our first criteria range is going to be wherever we find the word Microworld, which is the company range. Criteria 1 is Microworld, comma. Notice the arguments have now moved on to criteria range 2. So I can now add in my second piece of criteria. So once again, I like to work backwards. What is my second piece of criteria? Well, that is sales rep. Where am I going to find that? I'm going to find it in the job title range. So we're going to select the criteria range and then select the criteria, which is sales rep. I can then close my bracket because I only have two pieces of criteria. And when I hit enter, it's going to give me my result. And again, because I have a fairly small data set here, I could do a quick visual check. Let's look through for Microworld sales reps. So we have one just here. We have another one just here. And that is it. So basically my result should be the total of these two cells, and I can see that yes, that looks to be correct. What about if I have three pieces of criteria? Well, again, we can use sum ifs. Our sum range is the total sales. What is our first piece of criteria? Well, it's Microworld. We're going to find that in the range company. Our criteria is Microworld. Our second criteria range is going to be the job title, because the second piece of criteria is sales rep. And now we have a third criteria range. So we only want to see sales that are greater than $7,000. So criteria range 3 is going to be the total sales range. And our criteria is what we have listed in here. Greater than 7,000. Again, I could have hard-coded that in by typing in greater than 7,000, but if that changes, it makes it a lot more difficult. So I'm going to stick with the cell reference. Close the bracket, hit enter, and there I get my total. And I could carry on going. If I had 6 pieces of criteria, I could use sum ifs for that as well. And this works pretty much the same when you're using count ifs. For this example, we have 2 pieces of criteria. I'm looking to find the total number of employees at Computech with the job title Sales Manager. So for this, we can use count ifs this time. Criteria range 1. Well, our first piece of criteria is Computech. We're going to find that in this range just here. And our criteria is Computech. Our second criteria range is going to be the job title range because our second piece of criteria is Sales Manager. Close the bracket, hit enter, and there we go. Let's do the final one because practice does make perfect. Criteria range 1 is the company. Our criteria is Computech. Criteria range 2 is the job title. And our criteria is Sales Manager. Criteria 3 is less than 9,000. So we're going to select total sales. And less than 9,000 is our criteria range. Close the bracket, hit enter, and I get my result. Hopefully you're getting the idea, but let's just finish this off by doing the average. So we're going to say average ifs. Our average range is going to be our total sales. That's what we want to find the average of. Criteria range 1 is going to be the company, and the criteria is Computech. Criteria range 2 is the job title, and the criteria is sales rep. Close the bracket, hit enter, and there I get my average. Now it's worth noting that we have these formulas for min and max as well. So if I just show you a quick example, we do have a min ifs that we could use if I wanted to find the minimum value in a range. So if I wanted to find the minimum sale, I could choose the total sales as my minimum range. My criteria might be the minimum sales for Computech. So my criteria range would be the company. Criteria 1, let's just grab Computech from over here. I could carry on going if I had more pieces of criteria, but effectively I would do exactly the same thing. It's going to give me the minimum amount of sales for Computech. I just want to finish off this section on logical functions and if statements by talking a little bit about how you can use ifs to handle errors in your spreadsheets. Now, if we take a look at this example just here, we're fairly familiar with this data. This is that bonus spreadsheet we were looking at previously. Now, in this bonus column, if we take a look at the first formula, I've basically set up a formula to work out the bonus only for people who have a job rating of 5 or 4. And so you can see that reflected in this column. So where they have a job rating of 4 or 5, we have the bonus amount. Anything under 4, so 1, 2 or 3, we have an NA error in the cell. And that's because I haven't accounted for job ratings 1, 2 and 3 in this particular formula. Now, it might be that you are happy to leave your spreadsheet looking like this, but what I will say is that if you do have a spreadsheet that has lots of errors contained within cells, even if those errors are correctly there, which they are in this case, it makes your spreadsheet not only look a little bit messy, if you were to send this to somebody else who's maybe not familiar with the data, they might think that these are actual errors that need to be fixed. What would be much better here would be to add some meaning to these NA errors. So maybe instead of NA, I wanted to say no bonus, which makes it a lot clearer. Now we can do this by using error handling formulas. And if we jump up to the Formulas tab in this logical group, you're going to find the two that we're going to use in this lesson in here. We're going to take a look at if error and if NA. Now let's start out with if NA. Now what if NA will do is it will help you deal with any NA errors that you have in your spreadsheet. Now NA isn't the only type of error that you might see in cells. You might see a div error or a value error or a name error. And all of these different errors mean different things. But if you specifically have an NA error in a cell, you can use the if NA function to assign meaning to that. Now, as we do have an NA error, we're going to use that function. Now, what I want to do here is let's select the first cell that contains a formula. Let's jump up and edit this in the formula bar. Now, what we're going to do is we're going to type in if NA. That's the formula we're going to use. Now notice underneath this particular function has two arguments, value and value if NA. So in other words, value if we find an NA in the cell. Now the first argument, the value, well the value in this cell is generated by that if-s formula. So effectively the if-s formula is our first argument, it is our value. So we can click on the end, press comma, and now all we need to do is simply specify what we want to say in the cell if it comes across an NA error. Well, I want it to say no bonus. We need to add this in quote marks and close the bracket. So we've wrapped an if NA formula around our if-s formula. Hit enter and take a look at that. Now, if I copy this down, I've replaced all of those NA errors with something that is a lot more meaningful, a text string that says no bonus. Now, the if NA formula can only be used when you have NA errors in your spreadsheet. And as I said, there are lots of different types of errors that you can get in a cell. And for any other error, you can't use if NA to assign any meaning. That is where we would use the second error handling formula, if error. If error works in a very similar way to if NA, but it will handle all types of errors, not just NA errors. So let's take a look at this in action as well. If we jump across to the if error spreadsheet, if you recall, we put together a little formula here, and again it's an if-s formula, which gave us the day of the week when we enter in a day number. And what I said was that if somebody enters a day that isn't 1 to 7, so for example 8, it's going to produce an error because the formula doesn't account for that. Now in this case I am getting an NA error again, so I could effectively use the if NA error handling. But we're going to do this in a different way, and we're going to use if error instead. So if error we can use for any type of error, and we edit the formula in exactly the same way. So we're going to type in if error at the beginning. We have the same two arguments, value and value if error. The value again is going to be generated by our if-s formula, so we can go right to the end, press comma, and then we can enter in what we want it to say. Now in this case I wanted to say, please enter a number between 1 and 7. So what I'm doing here is basically giving the user a little bit of guidance if they enter an incorrect value. So let's hit enter, and there we have that piece of text. And if I choose a different day, it doesn't come up. But if I put in day number 10, I'm going to get that piece of text. So using error handling in this way can really help you keep your spreadsheets consistent, meaningful, and easy to understand for anybody who might be using them. The only takeaways here are if you have NA errors in the cell, you can use if NA or if error. If you have any other type of error, you can only use if error. It's time now to do exercise 1. And in this exercise, we're going to practice some of the skills that we've learned in this course on logical functions. So in the first part of this exercise, I'd like you to use either nested ifs or the if-s function and complete the prize money field in the table. And you'll notice on the right we have a smaller table which contains the information that we're looking for. And remember, if you're going to copy this formula down, then you need to make sure that you're locking those cell references in place. In the second part of this exercise, we have a similar table, but this time I'd like you to practice using COUNTIF, SUMIF, COUNTIFs, and SUMIFs. And I want you to use those formulas and complete the results in column H. So it's time to pause this video and give that a go. If you'd like to see the answer, then please keep watching. So in this exercise, we need to use nested ifs or the if-s function to work out the prize money. So I'm going to use if-s to do this. So we want our first logical test. Well, our logical test is if the medal is equal to bronze, F4 to lock that cell reference. If that's true, then they're going to get $100 in prize money, F4 to lock, comma. Because I'm using if-s, I can go straight into logical test number 2. If the value in cell D4 is equal to silver, then they're going to get $250 in prize money. And the last logical test is if the value in D4 is equal to gold, then they're going to get $500 in prize money. Close off the bracket, hit enter, and now we can copy this down. And if we do a quick spot check, let's take a look. Every time we have gold, we have 500, bronze, we have 100, and silver, we have 250. Let's take a look at the second part of the exercise. Well, here we need to use COUNTIFs and SUMIFs. So in the first table here, we need to find the number of athletes from the USA. Now we only have one piece of criteria, so for this I'm going to use COUNTIF. My criteria is going to be USA. Where am I going to find that? I'm going to find it in the country column, Control-Shift-Down arrow. I'm going to work on this up in the formula bar. And my criteria, because I don't have it contained within a cell, I'm going to need to type that in. So let's put USA in quote marks, close the bracket and hit enter. The next one, we have two pieces of criteria, so we need to use COUNTIFs. So our first piece of criteria is going to be that the athlete is from Australia, so our criteria range number 1 is going to be the country column, Control-Shift-Down arrow. Let's work on this up in the formula bar. Our first piece of criteria is Australia. Criteria range 2, well, our second piece of criteria is female. So our criteria range is going to be the gender column, comma, and our criteria is going to be F. Close the bracket, hit enter, and there I get my result. And finally, we have 3 pieces of criteria here, so COUNTIFs again. We're looking for athletes from the UK who are male who achieved a silver medal, so 3 pieces of criteria. Our first criteria range is the country, Control-Shift-Down arrow. Up in the formula bar once again. And criteria number 1 is UK. Criteria range 2 is the gender. So let's select that, Control-Shift-Down arrow. And our criteria this time is male. And our third criteria range is the colour of their medal. So let's select that. And this time we are looking for silver medals. Close the bracket, hit enter, and there we get the result. And finally, I asked you to work out the total prize money for various different pieces of criteria. So for this, we're going to use the SUMIF function. For the first one, we just need SUMIF because we only have one piece of criteria. Our criteria is the USA, so our range is going to be the country, Control-Shift-Down arrow. And then we need to put our criteria in quote marks. And then our sum range is going to be the prize money, Control-Shift-Down arrow, close that bracket and hit enter. Now we need to do SUMIFs because we have multiple pieces of criteria. This time we have the sum range first of all, so we're going to sum the prize money once again. Criteria range 1 is going to be the gender, and the gender we're looking for this time is female. And then our final piece of criteria is that we're looking for Canadian athletes only. So we want our criteria range to be the country, and our criteria is going to be Canada. Now the final one was a little bit unfair of me really, because I didn't actually show you this in the lesson. But I wanted to show you this in the exercise just so you can see something else that you can do with SUMIFs. Now for this one, we want to total the prize money for North America. So that's going to be the USA and Canada. So we have 2 pieces of criteria that are coming from the same column. So how would we do this? Well, if you worked this out, well done. It's not too hard to work out, but what we need to do here is basically perform 2 SUMIF calculations. So let's start out with our SUMIF. We want our range. So our criteria is going to be USA, first of all. So our range is going to be the country range. And our criteria is going to be USA. And we want to specify our sum range, which is going to be the prize money. Now what we need to do here is close off the bracket and then say that we want to plus and then go straight into the next SUMIF. So again, our range is going to be the country, but this time the criteria is Canada. And then finally the sum range is the prize money, and close the bracket. So we're just doing 2 SUMIFs and we're adding them together so that we can get the total for 2 pieces of criteria that are coming from the same column. Let's hit enter, and there is our answer. So hopefully you got most of those. I wouldn't expect you to get the last one, but if you did, very well done. I will see you in the next section. And there you have it, a heartfelt congratulations on completing this course. I genuinely hope this learning journey was as enjoyable and productive for you as it was for me guiding you through it. Now, as you transition away from this course, I encourage you to keep exploring, keep practicing, and continue pushing the boundaries of what you can achieve with Excel. Take a moment to reflect on your newfound skills that will undoubtedly open doors to exciting possibilities. Thank you so much for being part of this learning experience, and I look forward to crossing paths with you again in future courses. Stay curious and take care. Bye for now.